Welcome back. In this lesson, we are going to talk about integers and absolute values. And we're going to start off with an example of temperature. When we're recording temperatures, we might record things like a record high of 114 degrees Fahrenheit or maybe a record low of minus 34 degrees Fahrenheit. And our first question says, what does a temperature of minus 34 degrees Fahrenheit represent? And which temperature is closer to zero? Well, with 0 as our kind of our baseline, anything that's positive goes to the right of 0 on a number line, and anything less than that, 34 degrees below 0 or negative 34, would go to the left of 0 because it's less than 0. So positive numbers are greater than 0, negative numbers are less than 0. These numbers that are positive and negative, and we've talked about this already, are called integers. They are members of the number system called integers. Integers are any of the positive or negative whole numbers or natural numbers. And the 3 dots here just means that it continues forever. So they're positive or negative whole numbers or 0. And numbers to the left are less than 0. Numbers to the right of 0 are greater than 0. When we want to graph an integer, all we do is we find the point on the number line that corresponds to the integer, and that point is called its coordinate. We give that a special name. So if you see directions that say find the coordinate, that means find the number that corresponds to that. So on this number line at the bottom, we have graphed the coordinate -5 and the coordinate +4. -5 is to the left of 4 on the number line. -5 is on the left, -4 is on the right. So one of the things we can write is called an inequality when we want to compare two things. The number that's on the left would be less than the number on the right. And so we could say -5 is less than 4. Another equivalent statement we could write is 4 is greater than -5. So notice the open end of the inequality is always toward the bigger number. If we're going to compare integers, here's an example where we want to replace the little gray dot with either less than or greater than to make a true sentence, and it says -2 is either greater than or less than -4. So one of the ways we can figure that out is to plot both of those points on a number line. If you plot the coordinates -4 and -2 on a number line, since -4 is on the left and -2 is on the right, then we can say that -2 is greater than -4. We could also write an equivalent statement that says -4 is less than -2. That also would say the same thing in a different way. Absolute values, we've worked with these a little bit, and absolute values represent the distance between the number and 0 on a number line. That's all absolute value is. And we give absolute value a special sign. And if you take a look at the absolute value of -4 or the absolute value of +4, both of those numbers, -4 and +4, are 4 units away from 0 on the number line. So we give absolute value these vertical bars. That's the sign for absolute value. And what that says is how far away from 0 is -4? Well, it's 4 units away. Now remember, we can never have a negative absolute value. Okay, we can never have a negative distance. That wouldn't make any sense. So likewise, the absolute value of +4 is also 4. So whether we have a negative or a positive in there, the answer we get out from that absolute value is always positive. This example says evaluate the absolute value of -7. So if you plot -7 on a number line and ask yourself how far is -7 from 0, it is 7 units away, so therefore the answer is +7. Here's another example where we start adding variables. It says evaluate 8 plus the absolute value of n if n equals -12. Well, we're going to substitute in this -12 for n. So when we plug that in, 8 plus the absolute value of -12, well, what is the absolute value of -12? Well, we said before, whether it's positive or negative, it comes out of the absolute value as positive, so that would be 8 plus +12, which is equal to 20. Here's another example, 5 plus negative 6 in absolute values. And I think this would be a good time. Go ahead and try to pause the video and see if you can figure these two examples out on your own. And then I'll give you the answers when you come back. All right, 5 plus negative 6 gives us 5 plus positive 6. The absolute value of negative 6 is 6, which gives us 11. In the bottom example, we have two absolute values to figure out. So these are kind of like parentheses. You have to figure out the absolute value, what the value of the expression is inside of those absolute values first. So 5 minus 3 is 2. 8 minus 10 is negative 2. So we have the absolute value of positive 2 plus the absolute value of negative 2. Well, remember, whether it's positive or negative, it still comes out positive. So that's the same as 2 plus 2, which is 4. We can also use absolute value to find the distance between a number and 0 on a number line, just like we've been doing. Here's a word problem, and it says a tank that's used to keep a pet snake should be kept at a temperature of 80 degrees Fahrenheit, give or take 5 degrees. So this is kind of an example of tolerance levels. Graph the equation x minus 80 equals 5 to determine the least and the greatest temperatures. Well, instead of 0 being our center this time, 80 is our center because that's where we want to keep the temperature of that aquarium or that tank. And we have 5 degrees of tolerance, so we could go up 5 or down 5 from 80. So what values would be okay for the temperature of the tank? Well, if we go down 5, we're at 75. If we go up 5, we're at 85. So our solution set, we give these funny looking brackets here, is 75 to 85. On the lower end it's 75 and on the upper end it's 85. So anywhere in there would be acceptable. Here is a quiz for you to try. I want you to go ahead, and this is actually from our last section. I want you to go ahead and try to figure out these 5 problems, and I will probably collect this from you in class tomorrow. See you next time.